Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them Maria, which means seas in Latin. Other astronomers also made maps of the moon, and they used the term Maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
How about playing golf? Not on Earth, but on the moon. Let's journey back to a time 50 years ago when one astronaut turned the lunar surface into the most unusual golf course ever. Any golfer will tell you how tricky it is to avoid sand traps, but picture Alan Shepard, a NASA astronaut dealing with an entire surface that feels like super fine powder. During the Apollo 14 mission, he took a break to showcase some spacey golf skills for everyone watching from Earth. After his first shot, he excitedly made another. For him, it seemed the ball went forever and ever. Let's dial back to reality for a moment. Thanks to the research by the United States Golf Association, or USGA, we've got some numbers. They found that Alan's first moon ball traveled 24 yards, and his second stretched for 40 yards. Now, how does that compare to the average golf shots back here? In regular gravity, one usually swings to about 216 yards. Just goes to show, while we've upgraded our golf game on Earth with tech and training, the moon's low-gravity playground is a different environment altogether. Now, let's give Alan some props. Moon golf? Not as simple as you might think. His club wasn't one from your local sports store, it was a makeshift one. a moon sample collector with a club head stuck to it. Add to that the bulky spacesuit he had on. Imagine trying to swing wearing an outfit that's as stiff as cardboard. With all that gear, Alan could only muster a one-handed swing. Care to have a similar experience? Well, you might not be able to play golf on the moon anytime soon, but you can give it a shot underwater. Some say the conditions are similar. Here's where it gets even more interesting. The USGA didn't just take Alan's word on where the balls landed. They wanted to investigate. For starters, they used ultra-clear footage of the Apollo 14 mission. They also used some sharp images from NASA's special moon camera, launched in 2009. Using this imagery, they mapped out the journey of those two golf balls. Alan loved his unique golf club so much, he wanted to bring it back home. No big deal, right? Well, you see, in those days, astronauts would leave behind unnecessary items to make space for moon rocks. But not this club. So during the 70s, this interstellar golf club found a new home at the USGA Museum in New Jersey. Unlike regular golf clubs, this one had a twist. It was crafted from aluminum and Teflon. It was built to fold and fit snugly within the tight spaces of the lunar lander. How did this whole moon golf idea even pop up? Well, in 1970, golf legend Bob Hope paid a visit to NASA. Inspired by Hope's love for golf, an idea came into Shepard's head: moon golf. To turn his dream into reality, he collaborated with a golf professional and NASA's tech specialists. Together, they crafted a club that met NASA's strict safety norms. But hey, Alan didn't want this to be just a surprise stunt. Remember, traveling to the moon required very strict protocols. They couldn't just randomly have a picnic up there, you know? So, Alan made sure NASA officials agreed with this impromptu game of golf. They were initially skeptical, but eventually gave the green light after Alan passionately laid out his plan. He also promised he'd start playing if everything went smoothly on the mission. Determined to make it perfect, Alan prepped like a champ. The story goes that he'd put on his hefty spacesuit and sneak off to secret spots so he could practice. Decades later, he'd still be reflecting on his lunar escapade. He was the only golfer to ever swing on the moon. It's not just golf balls that astronauts left behind on their trips. There were actually a lot of objects left on the moon between 1969 and 1972, the year of the last moon landing. Each time you gaze up at the moon, remember that there's a cute family photo up there, some huge science gadgets, a small statue, a bunch of, well, human waste bags, and yes, some American flags. Years have passed by, and yes, technically those items are still hanging out there, though they've probably seen better days because of the harsh conditions on the moon. Some items had a special place in the astronauts' hearts and were meant to stay on the moon. But hey, leaving some stuff behind also meant they could bring back moon samples. You know the feeling. It's like when you need to make room in your suitcase for souvenirs when you're finishing a vacation. Does NASA have a complete list of things they left on the moon? Well, not really. In fact, one team tried to create a record of some of the items and reached an amazing list of 106 left there from the Apollo 11 mission alone. And that's not counting Neil Armstrong and Buzz Aldrin's famous footprints. The largest items at each landing site were mostly the sciencey stuff, like pieces of their lunar module and experiments to study the moon in depth. Then there were some beautiful tokens, like Apollo 11's plaque and a special disc with messages from leaders around the world. Some say the astronauts also took medals to remember some heroic cosmonauts, and they even left a gold olive branch, an age-old symbol of peace. Now, later moon missions had a little more fun, like Alan Shepard did with his golf game. But the award for the most heartwarming moment goes to Charlie Duke. During the Apollo 16 mission, he left a picture of his family up there. It's like he wanted them to be a part of the adventure. Although, a heads up, those photos probably didn't age well because of the moon's high exposure to the sun's radiation. There might just be an art museum up there on our satellite too. Let me explain. There's this tiny little art piece called the Moon Museum. It's a ceramic chip about the size of your nail. and it was crafted by an artist named Forrest Myers. This tiny object showcases miniature artworks from 6 talented people. Among them are even the famous Andy Warhol, the same artist known for his iconic soup cans and celebrity portraits. Forrest Myers said he wanted his mini museum to be on the moon, but there was a problem. NASA officials weren't exactly on board with the idea. However, Myers shared with the press that he handed over this art chip to an engineer working on the Apollo 12 mission. According to Myers, this engineer secretly tucked the Moon Museum onto a leg of the lunar lander. In case you haven't figured it out yet, these lunar landers don't come back to Earth after their mission. Take this with a grain of salt though, as NASA has never confirmed this story. You might wonder, why did they leave all these things? Sometimes it was about making a statement. Other times, it was purely practical. At one point, it was mentioned that during the Apollo 11 mission, for example, a decision needed to be made. The astronauts had to quickly figure out what was essential for their trip back home. They ended up creating a cleanup spot, tossing away things they didn't need anymore. Leaving things behind on the moon isn't that different from how we leave things behind on Earth. Just like archaeologists study our ancient leftovers to learn about our ancestors. The stuff on the moon gives us insights about those incredible lunar missions. Some things they left had done their job, like the pole for the flag or the camera they used to broadcast those steps on the moon. Even the tools astronauts used to collect samples were left because they had more precious cargo to bring back. Moon rocks. When it comes to the current state of all these items, scientists are not entirely sure. We do know that NASA's Moon Observer has spotted some of their shadows. They're still up there. The official gear was built to resist, so it might behave a bit better. But those personal items? They've probably seen better days.
Put on your shades because Mercury is a hotspot. From the surface of this planet, the sun looks 3 times bigger than it does from Earth, and the light is 11 times brighter. Mercury may spin slower than Earth, but it still knows how to have a good time. One day on this planet lasts a whopping 59 Earth days. But don't worry, a year on Mercury is only 88 Earth days long, so if you want to feel like a centenarian, just divide your age by not 0.25 or multiply it by 4. This way, you'll get your approximate Mercurian age. Easy peasy. And let's not forget about Mercury's funky orbit. For every 2 orbits around the Sun, it spins twice. That means each hemisphere gets a full year of daylight followed by a long night. Time zones would be a mess on this planet, so we'll just stick to GMT. Ugh, did anyone forget to take out the trash? Why does it smell of rotten eggs in here? Sorry, it's because we're on Venus now, and these stinky clouds don't smell like roses. Any planet's day is basically just how long it takes for it to do a full spin on its axis. Well, Venus takes its sweet time with this, way slower than Earth, in fact. So a day on Venus lasts a whopping 243 Earth days, or almost 6,000 hours. Now here's where things get a bit tricky. Because Venus's day is so long, we actually use Earth's day as standard for keeping time on the planet. That means there's only one time zone for the whole planet. Seems convenient, huh? Venus's year is about 225 days. So if you were celebrating New Year's Eve on Earth in the year 2000, that would have been Venus's year 3251. So to keep track of time of Venus, we can use the local year, made up of 225 Earth days, but every 3 years or so, there's an extra short year made up of only 224 days. Not that confusing. We have leap years on Earth too, but it works a bit differently. We've made it to planet Earth. Woohoo! How many time zones do we have on this big blue ball? Give me a drum roll. 24. And did you know that we can actually mess with time a little bit? Yup, in about 80 countries. Mostly in Europe and North America, we have something called daylight saving time. It's where we move our clocks forward an hour during the summer so we can soak up all that sweet, sweet sunshine. But beware, each country has its own rules about DST. So make sure you don't get caught snoozing when you're supposed to be working. And get this, some regions even have time zones that differ from UTC by half or quarter-hour increments. Can you imagine that the moon is getting its own time zone? The European Space Agency announced on Monday that it's time for the moon to have its own synchronized time zone. With more and more countries and private companies planning missions to our lunar neighbor, it's important that we all speak the same language when it comes to timekeeping. Right now, each mission carries Earth's coordinated universal time with it, which is fine when there are only a few missions happening at once. But with dozens of moon missions planned over the next few years, things are going to get tricky. We need a system in place to make sure everyone's on the same page, or we'll end up with different spacecraft out of sync with each other, and nobody wants that kind of chaos in space. Precise timekeeping is super important for communication and navigation, so we need to figure out a way to make sure everyone's on the same page. The ESA hasn't figured out exactly what form this new lunar time zone will take, but they're working on it. Should there be a single organization responsible for keeping lunar time? Or should we let the moon set its own time? And what about more granular time zones based on the sun's position? These are all important questions that need to be answered. When it comes to a day on Mars, it's not too different from a day on Earth. We're talking 24 hours, 39 minutes, and 35 seconds. A Martian year is 1.8 Earth years, which means the Earth year 2000 happened in Martian year 1063. Almost forgot. The Martian year has 668 local days. Phew! We sorted out the Martian calendar, but Mars will need local time zones. Because of its elongated orbit, the difference between summer and winter hours will be significant. Daylight saving time will be a thing on Mars. A year on Jupiter lasts almost 12 Earth years. Yeah, that's like a lifetime in dog years. But don't worry, they've got 12 seasons to keep things interesting, each almost as long as an Earth year, but a day on Jupiter only lasts 9 hours and 55 minutes. Also, since Jupiter doesn't have a solid surface, the clouds move at different speeds, so two free-floating atmospheric stations could experience different days. Hey, if we lived on Jupiter, we'd be in bad need of some cool app tracking all those things. Anyway, if we ever terraform Jupiter's region, most of the population will still live on Jupiter's moons, because the atmosphere is just too wild. And get this, the moon's revolution periods are connected, so we can use the same day counting system for all of them. On Io, we can have 2 standard Jovian days in 1 Earth day. How do we break that down? Well, we could have a minute of 53 seconds and an hour of 103 minutes. Or we could just stick with Earth's minute and hour and have a day that's 21 hours and 13 minutes long. How old are you? I'm 200 days old, and you? Sounds odd to you, Earth dweller, but dudes on Saturn count their age in days. A year on Saturn is crazy long, like more than 29 Earth years. Kiddos would only get a fraction of a year, while the oldest folks might get a whopping 3 years. So to keep track of time on Saturn, we could divide up a Saturnian year into 29 or 30 seasons. Oh, and fun fact, Saturn doesn't even have a solid surface, just rotating clouds that spin at different speeds. But we could still set up some cool research stations or helium extraction balloons to float around up there. 1 Uranian year lasts a whopping 84 Earth years. So to make things easier, we'll stick to using Earth years for our calculations, and natural Uranian years can be used for special occasions, like reaching 1 Uranian year old. As Uranus doesn't have a solid surface, the rotation period is all over the place. Only science missions and helium mining companies are brave enough to venture into the atmosphere. And get this, each moon has its own day and date system. Pretty confusing. Most people won't ever celebrate 1 Neptunian year old. 1 year on Neptune is like that's way too long for us humans to stick around. But don't worry, we'll still bust out the confetti and party hats for special occasions, like when it's been 2 whole years since the first spaceship hit up Neptune. As for the rest of the time, we'll just use Earth years for all our business needs. Pluto takes a whopping 240 Earth years to orbit the Sun, which is way too long to use as a year in our everyday lives. A day on Pluto is almost like a week on Earth. So, to keep track of time, we're going to divide that into 6 standard Plutonian days, 3 of light and 3 of dark. That means a standard day on Pluto will last slightly more than one Earth day. Now, because Pluto's axis is super tilted, using time zones would be pointless. So we'll just use one time zone for the whole system. Easy peasy. As for the standard Plutonian year, it'll be almost the same as the Earth year, about 343 days. But once in 10 years, we'll throw in an extra day just for kicks. That's all for now. See you on Pluto.
Soon we might start constructing loads of stuff on the moon. All because India's moon mission has recently detected sulfur near the moon's south pole. This chemical element can come in extremely handy for creating infrastructure on our satellite. It's the first time this chemical element has been discovered on Earth's natural satellite. This sought-after element is mostly found near Earth's volcanoes. Its appearance on the moon speaks volumes about the satellite's volcanic history and its past atmospheric conditions. The mission's rover detected this chemical element less than a week after touching down around 70 degrees from the moon's south pole on the 23rd of August, 2023. This historic landing on the lunar surface made India the fourth country to safely land a mission on the moon. It's also the first spacecraft to touch down so close to the south pole of our satellite. It's an area of strategic importance because it's believed to be home to deposits of water ice. If it turns out to be true, future missions might be able to harvest it and turn this water ice into drinking water or even rocket fuel. For 2 weeks, the lander carried out the data collection, mainly focused on the analysis of the moon's soil and its extremely thin atmosphere. Meanwhile, the solar-powered Pragyan rover started its quest to find frozen water on the moon. As for the lander, it demonstrated another amazing feat on the 3rd of September. The spacecraft fired up its engines and lifted itself for about 16 inches into the air. Then it made a tiny hop to land 12 to 16 inches away from its original position. It's kinda a big deal. Being able to get a lander back off the surface of the moon is essentially for future missions, showing that they can safely return soil samples or even astronauts back home after a lunar mission. In September, the Indian spacecraft was put into sleeping mode. The 14-day-long lunar night was approaching, and the spacecraft wasn't designed to collect scientific data during this period of time. So far, we've learned about a few major findings of the mission. One is related to measuring the temperature of the moon's topsoil at different depths. Intriguingly, the surface of the satellite in that region turned out to be hotter than expected. It was believed that the temperature could be between 68 and 86 degrees Fahrenheit on the surface, but it was around 158 degrees Fahrenheit, way hotter than it should be. The other discovery indicates the presence of several chemical elements, including oxygen. Besides, the data received from the spacecraft confirms the presence of aluminum, calcium, iron, titanium, silicon, and other chemical elements on the lunar surface close to the South Pole. The rover also used special instruments designed to measure quakes and rumbles beneath the lunar surface to detect some seismic activity. It brings us back to the sulfur detected thanks to the rover's spectroscope. Scientists are currently working on figuring out whether this element formed on the surface in a natural way or whether it's the result of volcanic activity or a meteor strike. Another astonishing thing found on the moon is a rock, and it may be the oldest known Earth rock. A 0.7-inch wide chip included in a large rock collection brought to our planet by Apollo astronauts might actually be a 4-billion-year-old fragment of Earth. This finding could help us paint a better picture of the intense pounding early Earth got at the dawn of its life. It could go like this. Soon after the rock formed, an asteroid impact might have blasted it from Earth. At that time, our planet's satellite was 3 times closer to Earth than it is today. The collision was so powerful that this chunk of terrestrial rock found its way to the moon. Later, this fragment got engulfed in a lunar breccia, a motley kind of rock. Eventually, the rock was brought back home to Earth by Apollo 14 astronauts. Even though scientists had found meteorites coming from Mars and the Moon before, it was the first time a rock from the Moon turned out to be a terrestrial meteorite. They also found out that the rock had formed in a water-rich environment at temperatures and pressures corresponding to those at around 12 miles beneath the surface of our planet. In 2019, China's Chang'e 4 mission made history by landing on the far side of the Moon. The mission's rover helped researchers visualize structures hidden deep below the surface of the satellite, revealing billions of years of lunar history. The Yutu-2 rover made this discovery with the help of its lunar penetrating radar. It imaged deep into the Moon's surface and listened to echoes of sound bouncing back off structures hidden from view under the surface of the Moon. It turned out those structures were resting at depths of almost 1,000 feet. The research suggests that the first 130 feet under the surface are made up of layers of dust, soil, and rocks. The instruments also discovered a concealed crater that must have formed after a large object slammed into the Moon's surface. Long, long ago, ancient lava was likely to be flowing deep underground. Researchers believe that the broken rocks around the formation might be debris produced by the impact. They also found that the volcanic rock layers were thinner the closer they were to the surface. Such a thickness variation of lava flows might mean a decrease in the number and magnitude of eruptions over time. So, lunar volcanic activity gradually dwindled since the Moon's formation around 4.5 billion years ago. On the far side of the Moon, there is one of the largest and oldest impact craters in our solar system, the South Pole Aitken Basin. Unfortunately, from Earth, you can only see its outer rim, which looks like a huge chain of mountains. It's a ginormous 8-mile deep dent, stretching for more than 1,500 miles in diameter and covering 1/4 of the Moon's surface. Astronomers are sure that this crater appeared when an asteroid collided with the Moon around 4 billion years ago. And now, look at this gigantic chunk of metal the size of 4 states of Connecticut. As for its weight in pounds, it's enough to say that the number contains 18 zeros. This mysterious mass is hidden about 180 miles under the Moon's surface, somewhere in the middle of the South Pole Aitken Basin. It was discovered when GRAIL, which stands for NASA's Gravity Recovery and Interior Laboratory mission, gathered data about our natural satellite. When examining this information, scientists noticed that in one place on the Moon's surface, there was a weird change in gravity. After researching this phenomenon, they concluded that something mysterious was weighing down the basin floor there. So far, researchers haven't figured out the origin of the bizarre lump, but there are several theories. One of them claims that the finding is a chunk of dense oxide, which appeared when the Moon was just taking its shape. At that time, the satellite was still covered with ancient oceans of magma, and the lump could be formed at the final stages of its cooling. However, most scientists support another theory, according to which the puzzling mass is part of the giant asteroid that once created the South Pole Aitken Basin. Since the thing is metallic, it's probably the iron-nickel core of the asteroid. There might be a labyrinth of lava tubes on the Moon. Not so long ago, astronomers received the results of underground topography and discovered a massive cave under the surface of Earth's satellite. It could be the result of the lunar volcanic activity that happened more than 3 billion years ago. Streams of lava hardened, creating a thick, hard crust on the outside. But inside, it kept flowing, melting the rock and creating tunnels and caves. Numerous small pits in the Moon's surface discovered by NASA seem to be the openings to such lava tubes. If this theory is confirmed, the underground tunnels might serve not only as a convenient location for human-crewed space missions, but also as much-needed water sources for astronauts.
It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions. But they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project. Figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000 from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must. That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
NASA has some incredible plans for the moon. For example, their next ambitious lunar program, Artemis II. They've set their sights on landing astronauts, including the first woman and the next man, on the moon by 2024. Artemis is all about building a sustainable presence on the moon. They're planning to establish a lunar gateway, a sort of space station in lunar orbit, which will serve as a jumping-off point for lunar landings. And let's not forget about the cool lunar landers. Scientists are developing the mighty Space Launch System rocket, which will launch the Orion spacecraft carrying astronauts towards the moon. Then there's the Human Landing System, a snazzy lunar lander that will gently touch down on the moon's surface, allowing astronauts to explore and conduct amazing scientific experiments. And NASA isn't going alone this time. They're teaming up with international partners, like the European Space Agency, to make this lunar dream a reality. But all these wonderful dreams might be ruined by something that seems super small and insignificant at first. Picture this: no atmosphere, no air to breathe, and suddenly, a mysterious haze and radiant beams of light appear at sunrise and sunset. It's as if the moon is putting on a celestial show. But there is a twist to this beauty. During the Apollo 17 mission in 1972, this beautiful sight made one of the NASA astronauts, Harrison Schmitt, sneeze and made his eyes water. He called it lunar hay fever. This mysterious fever affected all 12 moonwalkers. From sneezing fits to stuffy noses, those astronauts experienced symptoms as if they caught a cold. It took days for the reactions to fade away. This event led to a discovery about lunar dust and its darker side. When scientists found out about these rays, they rolled up their sleeves and delved into their origins. And here's what they discovered. Those radiant bands of light were actually caused by sunlight sneaking through layers of teeny tiny lunar dust. The dust was composed of small particles and sharp glass shards and was lurking everywhere. And it turned out that this lunar dust was a sneaky villain. It brought a whole host of problems. Astronauts who found themselves with impaired vision were just the beginning. The troublemaker went even further, damaging precious machinery and causing electronic malfunctions. It even had the audacity to corrode components and smelled like burnt gunpowder inside the spacecraft. Yikes. It clings to everything, coating surfaces like a mischievous blanket. It can clog up equipment, get into delicate machinery, and even mess with astronauts' spacesuits. In 1972, things got really hairy again. The Apollo 17 astronauts faced a nightmare. After just 22 hours of gallivanting on the lunar surface, their spacesuits suffered irreparable damage. Yes, you heard that right. Irreparable. The dust diminished astronauts' mobility, making it harder for them to move around and perform their moonwalks with grace. And no matter how hard they tried to clean it off, it clung on for dear life, leaving the spacesuits in a sorry state. So, as you can see, it poses some serious challenges for future moon missions. But our intrepid scientists aren't giving up. To solve this problem, they have to understand how lunar dust forms and why it's so darn clingy. They found out that it all begins with meteorite impacts. When these space rocks crash into the moon, they generate a fine dust that fills the air. Sometimes these impacts even cause minerals to melt, forming sharp glass shards that mix with the dust. Talk about a moon makeover. The dust is also filled with silicate, a material commonly found on volcanic planets. Silicate inhalation can cause serious lung problems for Earth's miners, so you can imagine the trouble it can cause on the moon. A recent study found that even a scoop of replica moon dust was toxic enough to destroy up to 90% of lung and brain cells exposed to it. But it gets worse. The low gravity on the moon allows those tiny particles to float around for much longer, penetrating deeper into the lungs. Imagine breathing particles 50 times smaller than a human hair for months. That's a recipe for trouble. And you see, on the moon's surface, things are a bit different than here. There are no rainstorms or strong gusts of wind to blow this dust away. There is also no atmosphere to protect the surface. So without the natural forces of wind and water erosion like we have on Earth, these dry particles stick around persistently. And to make matters more electrifying, the moon is constantly showered by radiation from the sun. This exposure gives the dust an electric charge. The solar winds create positively and negatively charged particles. The particles then buzz around, repelling each other and giving rise to those radiant bands of light that the Apollo 8 astronauts witnessed. It's like a disco party on the moon. ESA, the European Space Agency, has gathered a team of experts to study the lunar dust. They're working with simulated moon dust mined from a volcanic region in Germany to understand its behavior and effects. Engineers also need to find a way to protect future astronauts and equipment. Engineers in NASA want to create spacesuits that can survive not 1, not 10, but a whopping 100 extravehicular activities on the lunar surface. That's like spending 800 hours out there, exploring and having a blast. Besides that, NASA initiated the Breakthrough, Innovative, and Game-Changing Idea Challenge in 2021. It was open to clever university students from all over the world. These young minds put their thinking caps on and unleashed a wave of innovative solutions. For example, they proposed using special fibers that conduct electricity, inspired by fluffy chinchilla hair. Just like how chinchillas stay dust-free, these fibers would help keep the lunar dust at bay. A furry friend lending a helping paw, isn't that adorable? Another bright idea involved an electrically charged brush activated by UV radiation. It's like a magical wand that zaps away the dust with a flick. Abracadabra, lunar dust be gone. And let's not forget the fabric inspired by clever insects. These insects have pollen-collecting structures that repel unwanted dust. So our ingenious students thought, why not mimic that? They designed a fabric with similar properties, creating a shield against the sneaky lunar particles. What's remarkable about these ideas is that they all use the power of charge to fight the dust. They cleverly repel it from the spacesuits, keeping them clean and protected. And even though all these ideas sound pretty great, scientists in NASA unleashed another, even better solution: carbon nanotubes. It's a great way to revolutionize spacesuit fabric. What makes these carbon nanotubes so special? Well, they possess some amazing superpowers. First off, they're superconductive, meaning they can carry electricity like nobody's business. It's like having a lightning bolt trapped inside a microscopic tube. Not only that, but these carbon nanotubes are tougher than the toughest meteors. They have the strength to withstand the harsh lunar environment, where even a speck of dust can cause trouble. Imagine having a suit made of a material that's stronger than Superman's cape. So, NASA's scientists decided to weave these extraordinary carbon nanotubes into the spacesuit fabric. The electrodes were carefully integrated into the outer layer of the fabric, making it a force to be reckoned with. But how do they banish the lunar dust? Well, here comes electrifying science again. When activated by a special alternating current, the electrodes create powerful electric fields. These fields work like magnets, repelling both charged and uncharged dust particles away from the spacesuit. Picture this like a dance party, where the dust particles are the uninvited guests, and the electric fields are the bouncers, swiftly escorting them out. Thanks to this technology, lunar dust doesn't stand a chance against our astronauts. Also on the bright side, the lunar soil can be used to make bricks for shelters. It can also help extract oxygen for astronauts to survive on the moon for long periods of time. When life gives you lemons, make a lemonade, right? So, let's cheer on our NASA Dream Team as they embark on this epic lunar quest. Let's hope that they succeed in their findings, and the next moon mission won't be a big problem. Stay tuned.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation: phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus,
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the sixth largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
it was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contained phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that. What a nice cosmic family. Meet Mars. I bet you've met him before. These 2 little guys are Phobos and Deimos, Mars's small moons. But it seems like Mars isn't treating the little ones the right way. Phobos and Deimos are believed to be captured asteroids. However, Phobos is gradually moving closer to Mars due to gravity, and it is predicted that it will eventually be destroyed by the planet's gravity within the next 35 million years. I won't be around then. So, I imagine this will result in a ring of debris around Mars, similar to Saturn's rings. However, this process is a natural phenomenon and not an act of destruction by Mars. Apparently, Phobos is getting ripped apart by the crazy gravitational forces of the red planet. But wait, there's more! Phobos has these crazy parallel grooves all over its surface. We used to think that they were from an asteroid crash, but now scientists think they're actually from Mars's intense gravity pulling the moon apart. Talk about a rough ride! Scientists have this wild idea that when a little guy like Phobos gets too close to a big guy like Mars, it starts to stretch out towards it. They call it the tidal force. Phobos is predicted to get stretched out so much that it'll actually break apart. Crazy, right? And the debris from the moon will form a tiny ring around Mars, just like Saturn's rings. Now, some people thought that Phobos' tiger stripes were caused by tidal forces before, but that theory got shut down because the moon is just too darn fluffy. But now, these genius researchers ran some computer simulations and found out that maybe there's a hard shell underneath all that fluff that could create grooves on the surface. But don't worry. At the rate Phobos is going, it's going to crash into Mars in about 40 million years. But if tidal forces are already tearing it apart, it might not even last that long. However, we'll still have the chance to learn more about Phobos. NASA just picked 10 rockstar researchers from all over the U.S. to join the science working team for JAXA's Martian Moons Exploration, or just MMX mission. As NASA-supported participating scientists, they'll be helping JAXA explore the 2 Martian moons, Phobos and Deimos. And get this, they're even planning to land on Phobos and grab a surface sample. The mission is set to launch in 2024, and we'll get our hands on that sample in 2029. 7 of the lucky researchers will be using the MMX flight instruments to conduct their research. Phobos is a real oddball. It's only 17 miles wide and orbits Mars at a distance of 3,728 miles, to be precise. Now that's way closer than Earth's moon, which takes a whole 27 days to orbit us. But Phobos is in a death spiral toward Mars and is slowly falling towards the planet's surface at a rate of 6 feet every 100 years. But there must be a reason why Mars is acting that nastily, right? What if it's all just because of plain vengeance? Well, okay, picture this. Mars is minding its own business, being all hot and watery like a young Earth. It's got a sweet magnetic field that's protecting it from cosmic radiation and keeping its atmosphere nice and thick. Hey, life is good. But then, at least 20 asteroids, each the size of a small country, come crashing down on Mars like a giant game of cosmic whack-a-mole. One of them even leaves a crater that's almost 2,000 miles wide. Now imagine how Mars must feel with 2 asteroids being its moons after what other asteroids did to the red planet. All these impacts are like a massive punch to Mars's gut, and its already weak magnetic field is knocked out cold. The core gets all overheated and can't circulate properly, which means no more magnetic field to protect the planet. It's like as if you were wearing nothing at the depth of the Mariana Trench. If it were possible, you'd be defenseless and chilly. It's basically what happened to Mars. So now, poor Mars is out there in the cold, unprotected from all those nasty cosmic rays. It's like going outside without sunscreen. Not a good idea. But at least we can learn from Mars's mistakes and make sure Earth doesn't have the same fate. Maybe we should start investing in some asteroid insurance. But trust me, the red planet isn't mean at all. It's actually pretty friendly. While Mars may seem to be pretty tough for Phobos, there's something that might be thriving with Mars's help. So get this, a team of scientists found a way to grow rice on Mars. Yep, you heard me right. They used MMS, not the outdated way to send pictures, but a special soil called Mojave Mars Simulant. It's supposed to mimic Martian soil. And here's the catch, Martian soil has these nasty percolate salts that can be toxic for plants. So the team grew 3 types of rice, 1 normal and 2 gene-edited with mutations that make them better at handling stress like drought or salinity. And guess what? The mutant strains were able to root in soil with 1 gram of percolate per kilometer. Take that, Martian soil. But hold up. The rice grown in the MMS didn't turn out as great as the ones grown in regular potting soil. So the team decided to mix a quarter of the potting soil with the Martian simulant, and looky there, the plants started developing better. Now these scientists aren't just thinking about feeding Martians. They also want to see if their findings can help grow crops in places on Earth with high salinity. And get this, the whole project started when 2 researchers met for coffee and decided to try growing plants together. Well, isn't that nice? I suspect you're about to say, hey, but if you want to grow rice on Mars, you'll have to ship insane amounts of water from Earth, and it's not easy to quench this plant's thirst. You're right. You need about 449 gallons of water to only grow a pound of rice. But guess what? Scientists made a groundbreaking announcement at the Lunar and Planetary Science Conference in Texas. They found a relic glacier near Mars's equator. That's right, water ice on Mars, even near the equator. This is huge news, and could mean there's even more ice just below the surface. It's not just any glacier, it's a relic glacier that's estimated to be 3.5 miles long and up to 2.5 miles wide. It's like the size of a small town. It's got all the features of a glacier, including crevasse fields and moraine bands. But get this, it's not actually ice. It's a salt deposit that formed on top of the glacier while preserving its shape. So, how did this salt deposit form? Well, it turns out that volcanic materials blanketing the region might have something to do with it. When these materials come into contact with water ice, sulfate salts may form and build up into a hardened, crusty layer. Over time, erosion removed the volcanic materials, exposing the sulfates and revealing the glacier's unique features. This glacier is young, likely from the Amazonian geologic period. That means that Mars has had surface ice in recent times. Who knows what other icy secrets Mars is hiding? But hold your horses, there's still more research to be done. Scientists need to figure out if there's still water ice preserved underneath the salt deposit, or if it has disappeared entirely. And if there is still water ice at shallow depths near the equator, that could have major implications for human exploration. Imagine being able to extract water from the ground at a warmer location. That would be a game changer. So let's see what else these scientists uncover about our favorite red neighbor. Maybe someday we'll even get to visit that Salt Glacier statue in person. See you next time. The first trip intending to land on the moon made by human mammals took 3 days, 3 hours, and 49 minutes. The Apollo 11 astronauts needed to travel some 240,000 miles to get there. Their plan was to touch down on a place on the moon called the Sea of Tranquility because it had good visibility and the terrain there was pretty smooth. Well, up until the last few moments of the flight, when all these big craters appeared that they had to avoid, they finally landed with just 30 seconds of fuel left. Ooh, that's called cutting it close. Hey, how would you like to land in your jetliner with only 30 seconds of fuel left? So, now you know. Later that day, July 20th, 1969, Neil Armstrong stepped onto the lunar soil, saying, "That's one small step for a man, one giant leap for mankind." The astronauts were planning to sleep before the first moonwalk, but they chose to go outside earlier than scheduled. They obviously couldn't sleep. I mean, could you? Since that first visit, our lunar satellite has accumulated quite a collection of memorabilia from Earth. Let's look at some of the most important and weird stuff that humans have left on the moon. Take footprints, for starters. I know they're not technically objects, but the marks left by Neil Armstrong and Buzz Aldrin do show that humans have been there, just in case someone or something else drops by. Since the moon doesn't have any wind or rain, the footprints should still be relatively untouched. NASA put in a lot of effort to make sure these footprints stay protected, as well as the location of the initial moon landing. Rules were set into place for future missions to make sure they wouldn't alter the initial site, as it's an important piece of history, kind of like a national park that you can't get to. Now, astronaut Charles Duke wanted to leave a photo of his family on the surface of the moon. If that didn't make him the best dad ever, I don't know what would. He did take his family to the moon, right? On the back of the picture, he wrote that he had come from Earth. He also added the date when he landed on the moon, which was April 20th, 1972. Now, there's a good chance that his family is no longer visible in the picture today. Because of the exposure to strong solar radiation, the colors in the photo have likely faded away by now. To this day, Charles Duke remains the youngest person to visit our moon. He was 36 years old at the time of his mission. Now, there are many flags on the surface of the moon too, but the flags left there must have had a similar fate to Duke's photo. They're most likely discolored by now. During each lunar landing, a flag was planted as a tradition started by Apollo 11. This tradition continued with all future Apollo missions. The flags were made using metal poles to stretch the flag out so they could be seen on the moon. But since there's no wind, they never move. Back in the 1600s, astronomer Galileo Galilei dropped two objects of different weights from the Leaning Tower of Pisa to show that the speed of the fall would be the same. In 1971, astronaut David Scott repeated the experiment on the moon and proved Galileo's theory correct. He dropped a feather and a hammer at the same time, and as predicted, they both landed on the moon's surface simultaneously. Fun fact, the feather came from the Air Force Academy's Falcon mascot named Baffin, with its permission, of course. These objects were both left on the lunar surface. Now, what about art pieces on the moon? We've left some of those out there as well. The Fallen Astronaut sculpture was made by a Belgian artist and left behind by the astronauts of the Apollo 15 mission. It was a small statue requested by David Scott, the head of the mission. Scott said the statue was to memorialize the astronauts and cosmonauts who gave their lives for the advancement of space exploration. Meanwhile, astronaut Alan Shepard even played some golf on the moon during his mission on Apollo 14. He brought a golf club head, yes, he got permission first, and attached it to a tool. Then he tried to hit 2 golf balls. Hey, it's hard to do in a clunky spacesuit. He did better on the second one. It's safe to say that he didn't bring the golf balls back, and they should still be there on the moon. There's yet a message from Queen Elizabeth II there. The monarch prepared a message which accompanied Neil and Buzz to Tranquility Base during the Apollo 11 mission. It was written on a tiny disc the size of a coin and also featured messages from over 70 other leaders from all over the world. I'll bet the printing was really small. Her message said she was proud of the astronauts and their accomplishments and hoped their journey would benefit all of humanity. The disc was then placed where Armstrong and his team first landed on the moon. After they returned, they met the Queen at Buckingham Palace. Their encounter was memorable too. Neil Armstrong almost couldn't speak to the Queen at all because he had a cold. Another astronaut named Mike Collins was so nervous about the protocol, he almost fell down the stairs. Now, some objects that exist today on the moon weren't left there on purpose. One of the most interesting moments of the Apollo 11 mission was when Neil and Buzz were getting ready to go back to Earth. They had to chuck everything they didn't need so they wouldn't be weighed down at liftoff. They also needed to store all the rock samples they had gathered from the lunar surface. This created a toss zone that archaeologists could potentially study one day. Waste like this acts as a timeline for Earth's history, but it can also help us understand what happens to objects that spend a lot of time on the surface of the moon. Now, most astronauts became pretty sentimental when strolling on the lunar dust, and who could blame them? They were thousands of miles away from their families. So that's why, in 1972, NASA astronaut Eugene Cernan wrote his daughter's initials, TDC, in the dust on the moon, and gave a speech before leaving. He said, "We leave as we came, and hopefully will return with peace and hope for all." Unfortunately, this marked the end of the Apollo lunar missions. Technically, his daughter's initials should still be there on the surface of the moon, just like all the astronauts' footprints. Can you believe it's been more than 50 years since people started exploring the moon? No worries though, as NASA's been preparing for future lunar explorations for quite some time. This new mission is called Artemis, and it aims to build some sort of settlement out there. This way, the moon can be studied in safe conditions for longer periods of time. For starters, NASA launched Orion, a spacecraft without a crew on board, to orbit the moon and come back to Earth. This was a test drive. Before NASA transports people to the moon again using newer technology, all safety measures need to be worked out and confirmed. But one day soon, Orion is going to take astronauts back to the moon. One cool thing about this spacecraft is that it comes with a launch abort system, which is meant to keep astronauts safe in case something goes bad during the launch. It also features a special service module, which is like a battery that fuels and propels Orion through space. It also supplies astronauts with water, oxygen, and power, and provides temperature control. But Artemis also looks to build a long-term human settlement on our satellite somewhere around the 2030s. However, searching for a cozy place on the moon isn't as easy as you'd think. Thankfully, NASA specialists produced an ingenious idea. They found some lava tubes on the surface of the moon, and they have pretty steady temperatures inside. The main problem with the first moon landing back in 1969 was extreme temperature fluctuations. So these caves might be the perfect solution. Not only is the temperature in there suitable for humans, but they could also help shield astronauts from cosmic rays, solar radiation, and meteorites. It's also good news that we have similar structures here on Earth. Before we get back to space, we can study them to better understand those found on the moon. Here on Earth, these holes form once the top of a stream of lava solidifies, and the molten rock inside drains away, creating this tube.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
You know how it all started 13.8 billion years ago with the Big Bang? Bam! No, wait, I can do better. No, never mind. And the universe has been expanding ever since. At its young age, it was all made of gas, mostly helium and hydrogen. For billions of years, the gas has expanded and cooled down. Meanwhile, galaxies, stars, and other mysterious things in space we try to explore today formed because of gravitational forces. And in that chaos, just like in middle school, about 4.6 billion years ago, our magnificent planet was born too. It all started as a disk of gas and dust that orbited the young sun, just the same way it was with the rest of the planets in our solar system. This disk consisted of dust particles of different sizes and gas. They were circling the sun at different speeds and in orbits that weren't stable and predictable. They were bumping into each other all the time. These particles grew from very small grains of dust into boulders, then later into bigger objects called planetesimals that had a range from miles to hundreds of miles in diameter. And these planetesimals that were orbiting the sun within the disk had gravitational force strong enough to pull other objects from the neighborhood out of their orbits and collide with them. As they were constantly hitting each other, they got bigger and bigger until some got to the size of thousands of miles in diameter. That's nearly the size of Mars and the Moon. We know these things because of meteorites. They come from different places all over our solar system and bring all kinds of materials to our planet, giving us something cool to study and learn about our solar system and how it formed. These materials include very small pieces of dust and rock that have gone through the chaos and survived those rough times even before the planets were created. Meteorites also brought pieces of asteroids and planetesimals left behind after the planet-forming process ended. As these objects were forming, some radioactive elements were left trapped inside the minerals that, again, were part of them. That's how scientists could tell how old they were. But the final stage of Earth's formation, and generally this whole chaos that was happening in our solar system, may have taken a little bit longer, possibly even up to 100 million years more. That's when the last enormous impact was, and the Earth finally reached its full size. What actually happened is that it hit another object which was nearly as large as Mars. This collision was so strong that the impact produced enough energy to vaporize some of the metal and rock, both from the Earth and the Mars-sized object. And this vapor created a disk that was surrounding our planet. That disk cooled and clumped together at some point, which is when we got our moon. Our moon was the result of impact debris, which was a combination of hot gas and molten rock. There are some theories of how the moon formed, though. One claims it broke off from the Earth. Another one says the moon formed somewhere else in our solar system, and at some point, as it was wandering around, it got so close to Earth that it ended up captured by its gravity. And fans of the third theory believe the moon and the Earth formed at the same time, from the same protoplanetary disk. Before the moon formed, the Earth was a much different place. If you could have just one day on Earth without the moon, you'd be first surprised by the days and nights. They wouldn't be as stable as they are today because the moon helps to keep the Earth's axis stable. Days were shorter back then. The Earth had been rotating much faster before the moon formed. Its gravitational pull slowed the rotation of our planet, which means days got longer. The Earth's rotation is getting slower through time, but at a really small rate. Some predictions say that in 1 billion years, a typical day will be between 25.5 and 31.7 hours long. If 24 hours is not enough time for you, just wait 1 billion years. But yeah, if you're the type of person that likes to take things slowly, you definitely have to hurry back then. Although there weren't many things you could do back then than to fill your time besides, sailing across the hot lava, collecting rocks, or hoping not to get hit in the head by some fierce meteorite falling onto our planet. Ow! But if you were patient enough, maybe you'd see something really cool: water coming onto our planet for the first time. There was a rain of fiery meteors coming from the sky, and they kept slamming into our young Earth. It looked devastating at first, but some of this falling debris probably held water. Many believe the asteroids and comets that bumped into our home planet carried tiny amounts of water. But considering this meteorite shower lasted more than 20 million years, maybe even up to 200 million years, it's not that unusual that after a while, puddles of water started to collect across the surface. And as the water evaporated within the atmosphere, it would fall back down, forming lakes, rivers, seas, and eventually oceans. Only at that point, there was a chance for some primitive life to evolve sometime in the future. Earth started its transition from a hot ball of magma to the world we know today. Before that, it would be too hard for life to exist there. Even if it had happened somehow, all those meteor and asteroid collisions would have probably destroyed it. Also, you wouldn't be able to survive without an oxygen tank. The Earth did have an atmosphere, but it wasn't like the one we have today. Scientists believe it was composed of water vapor, methane, ammonia, and some other gases released from volcanic activity. Basically, it was too toxic, since there were volcanic eruptions all the time. And the temperatures were way higher, so just standing at these early stages of Earth wouldn't be such a pleasant experience. Also, there could even be some form of life at that time. In its early stages, when everything was so chaotic, it wasn't covered in oceans, trees, or stunning landscapes like today, but in molten magma. I mean, the earliest form of life we know about are fossils of microorganisms found in hydrothermal vents, and they're thought to be 1.4 billion years old. And scientists assume the earliest time for life to show on Earth could be 4.2 billion years ago, give or take. So, with the right equipment, you could even see some single-celled organisms like bacteria somewhere across our chaotic planet, even before the moon was there. The moon's gravitational pull on the Earth creates tides in the ocean, which means it probably helped mix and circulate ocean water, maybe even shape them. The tides without the moon would be much smaller, because the gravitational pull is what causes the tides to rise and fall. The moon also affects life in the ocean. Over time, animals in the ocean have changed and adapted to the changing water levels caused by the moon's gravity. Even just the moonlight has a big effect on sea creatures. For example, corals use the moon's cycle to release their eggs at the same time and with stronger tides to help carry the eggs. Baby sea turtles use the moon's light shining on the water to guide them from their nests to the ocean. Who knows which directions life on the Earth would have taken if, at some point, billions of years ago, we didn't get our lunar buddy to follow us along the way.
So Mars has two moons, Phobos and Deimos. And apart from the bizarre shape, there's nothing remarkable about them, except for one thing. Not so long ago, scientists discovered a strange phenomenon on the surface of Phobos, and they still can't find any explanation for it. What is this phenomenon, and what does it tell us about the history of our solar system? Let's find out. American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. Did you know that all the planets in our solar system are named after Greek and Roman deities? For example, Mars or Ares is the famous deity of war. That's why the satellites of this red planet were named after the sons of Ares, Phobos and Deimos. These beautiful names actually have creepy meanings: fear and horror. In 1971, NASA's Mariner 9 telescope took the first pictures. That's how we found out that these guys weren't at all like our moon. They had this weird shape, a strange and unstable orbit. Moreover, there are no other moons in the solar system that move as close to their parent planet as these two. Well, they are its sons after all. But even though they are very close to Mars, if you were standing on the surface of the red planet, you would hardly be able to see them. That's because the curvature of Mars hides Phobos and Deimos from view. Even if you were somewhere on the equator, Phobos would look like an ordinary asteroid to you, and Deimos would look like a star. All because these satellites are basically crumbs compared to our moon. They're the smallest and least bright moons in the entire solar system, which is ironic considering their mighty names. Anyway, it seems that everything should be pretty clear with these two satellites. But nope, there's a problem. You see, scientists reconstruct the history of space based on the traces found on different space objects. Dents, scratches, cracks, all these things can tell us what happened billions of years ago. For a long time, scientists were sure that, just like their Greek prototypes, Phobos and Deimos were twins. But then, NASA's Viking orbiter took new photos of the satellites, and that's when they discovered a significant difference between the two. The entire surface of Phobos was covered with huge grooves. Those were a series of long, deep pits stretching from one end of Phobos to the other. You may say, what's the big deal? All space objects have this kind of stuff on them. And yeah, there are other satellites with similar grooves and scratches, but none of them has as many as Phobos. It's completely covered in grooves, and they're huge, up to 12 miles long and 660 feet wide. And that's not all. Some of these grooves intersect with others. This means that Phobos has experienced not one, but many traumatic events. But what exactly happened to it? Actually, scientists are still not completely sure. However, they have a few ideas. And these theories can tell us not only about the past of Phobos, but also predict its future. Theory 1. Asteroid impact. Well, the first suspect is quite obvious. There's a large, almost 6-mile wide crater on Phobos. It's called Angeline Stickney. It was named after the wife of Asaph Hall, the scientist who discovered the satellites. Adorable. So that's what the first theory sounds like. Once upon a time, an astronomical body crashed into Phobos. The impact was so strong that it left a large crater. And the effect of the collision left a bunch of grooves everywhere on Phobos. It sounds logical at first. However, scientists have noticed a flaw in this theory. They learned that these grooves actually formed not inside the crater, but next to it. So it wasn't a collision that created them. Besides, what about those grooves that intersect with the others? Or is it just a big cosmic coincidence? Well, the search for truth continued. Theory 2. It's all because of space debris. Yes, there's a difference between these two theories. In this case, the grooves aren't a direct consequence of the collision. Rather, it goes something like this. Something crashed into Phobos. This impact caused a bunch of rocks to be thrown into space. Some of them were lost in the universe forever, but others were small enough to be pulled back to Phobos. Passing next to the moon at a steep angle, they would crash into it, jumping away, and so on. And since the gravity of Phobos is very weak, perhaps they couldn't stick to it. In other words, these rocks were continuously pulled toward and pushed off of the satellite for many, many years. This theory explains the intersecting grooves. It's because the rocks were constantly falling into those places. It sounds quite logical, but there's another problem. We don't see any boulders on Mars or on the surface of its moons. But all this debris was supposed to get trapped by gravity and remain somewhere in the planet's orbit. This, or simply become part of Phobos. In other words, if this were true, we'd find evidence of this theory under layers of dust. But that didn't happen, so this explanation didn't satisfy astronomers either. Therefore, they continued to look for the culprit. Maybe the grooves have nothing to do with Stickney Crater at all. Maybe the real culprit is something else, something even more powerful. Could it be Mars itself? Theory 3. Mars is a twist villain. The previous theories imply that Phobos and Deimos were originally pieces of Mars. Like once upon a time they broke away from it and became satellites, just like our moon. But what if that wasn't the case? Observations made by NASA's Mars Global Surveyor show that Phobos and Deimos are made up of elements which are mainly found in meteorites and asteroids. So, what if Phobos and Deimos are asteroids? There's an asteroid belt between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists have suggested that once upon a time they belonged to this belt. However, one day they flew out of it, and then gravity pulled them to Mars. This phenomenon is called asteroid capture. It's very strange though. Yeah, the asteroid capture isn't uncommon, but these two have been flying next to Mars for what, billions of years? It's weird that their orbits have remained the same. In addition, the atmosphere of Mars is very rarefied, and because of this, it could hardly capture any asteroids. In theory, they should have separated from Mars at the first opportunity. However, this didn't happen. It means that somehow they got stuck, and Mars immediately began to destroy them. Yep, an unexpected twist. In this version, Mars turns out to be a villain. By studying the past, we've found some evidence of future crimes. The mysterious grooves of Phobos could be caused by tidal forces between Mars and Phobos. The Moon and Earth also exchange these, slightly distorting each other. But since Phobos is much closer to Mars, the impact of gravitational forces is much stronger. In other words, the gravity of Mars is gradually destroying Phobos. Every 100 years, the satellite gets 0.7 inches closer to Mars. It also shrinks as much as 6.5 feet, becoming even more fragile and weaker. The smaller it gets, the more the tidal forces impact it, creating strange grooves and scratches on Phobos. Yep, somewhere in 30 to 50 million years, Phobos will either collide with Mars or disintegrate and turn into a bunch of small rocks. And then Mars will also have rings, like Saturn and Neptune. That's why Phobos is called the doomed Martian moon. Anyway, these are all only theories, but the dramatic backstory of Phobos gives us an idea of how dynamic extraterrestrial objects can be. The more we learn about them, the more we discover about the secrets of the origin of not only Mars, but also other objects in our solar system. If one day we really colonize Mars, studying its moons can help us a lot. Let's hope that the upcoming MMX mission will reveal some of the most exciting secrets Mars's moons are hiding. It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail, and every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
Back when Apollo missions were launched, astronauts returning from the moon claimed that moon dust, the gray sand-like dust covering much of the satellite's surface, smelled and tasted, yes, they actually tasted it, like gunpowder. But the stuff moon dust is made of is nothing like gunpowder. About half of its composition is silicon dioxide glass from impacts with meteorites. They hit the surface of the moon at incredible speeds. Whoa! The high temperature makes the topsoil fuse into glass, and the impact shatters it right afterwards, creating the gray and clingy dust. The rest of moon dust ingredients are minerals such as iron, calcium, and magnesium, while old-fashioned gunpowder consists mainly of saltpeter, charcoal, and sulfur. In other words, moon dust shouldn't smell like gunpowder, but it does. Besides, when astronauts brought samples of it back to Earth, there was no smell left at all. One explanation could be that the moon is similar, in a way, to Earth's sand deserts, like the Sahara. It's extremely dry and arid. When you sniff the air in a desert, you don't smell anything. But if you get caught in the rain there, the moisture will raise all kinds of odors from the ground that were previously trapped in the dry sand. With moon dust, it might be similar. While on the surface of the moon, it doesn't smell at all. Not that the astronauts could sniff at it wearing their spacesuits, though. But when brought back inside the landing module, the dust came into contact with moisture in the air and started emitting its strange odor. Another reason for this could be a reaction of moon dust to the solar wind. Ionized particles from the sun hit the bare surface of the moon and stay there. There's no thick atmosphere to protect it from those ions, so they travel freely right to the ground. They're very lightweight, so they can fly off and sort of evaporate from the slightest of nudges. And when astronauts took the moon dust samples to the landing module, those particles could have started moving around and giving off the specific smell. This might also explain why the samples didn't keep their odor when brought back to Earth. Since the particles are so light, they might have flown off the samples already in the landing module. And when they were placed in airtight containers, there were little or no ions left on them. Another explanation is that those airtight containers weren't so airtight after all. Moon dust is basically very small crystals with extremely sharp edges. They unexpectedly made tiny cuts in the seals, letting in air and moisture, and so the ionized particles leaked out of the containers. Scientists believe they should study moon dust on the surface of the moon itself to find out everything about its properties. Now, there are hundreds of thousands of craters on the surface of the moon made by falling asteroids, but one of them drew a lot of attention. It turned out to not be just an impact crater, but a tube, looking most like an entrance to a cave system. Scientists found a specific echo pattern that suggested there was a hollow area beneath. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field. Researchers believe there could be an entire geological wonderland under the surface. It could be a good shelter for astronauts landing on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. Wide range of temperatures, low atmosphere, no magnetic field would protect life on the surface from things like radiation or solar wind. Astronauts wear spacesuits. They can't protect them over long periods of time, but a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, and that's how an empty tube appears. Our planet also has lava tubes, but they're not as big as the one found on the moon. Back in 1178, I wasn't around then, at least 5 people in England claimed they had seen the moon split into 2 from its upper tip. It was in the shape of a crescent at the time of the event. When the crack widened, fire started blazing from it, which the single monk who chronicled it described it as a flaming torch sprang up, spewing out fire, hot coals, and sparks. Then the moon started shifting around and pulsating, but soon stopped and turned a slightly darker shade. The event didn't receive much attention from scientists, though, until the second half of the 20th century. Researchers studied the chronicle and figured out there was a huge 14-mile-wide crater on the surface of the moon at about the spot described in the book. Only a very large asteroid could have left such a scar on the satellite's face. And when they investigated it more closely, they found out it was pretty recent by astronomical standards. In fact, it really could have appeared about 800 years ago. But in that case, millions of fragments from the asteroid and the moon would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would have definitely been in the archives. But that didn't happen. In addition, many scientists argue that the crater isn't as young as it might seem. The most popular and justified theory is that it's about 1 to 10 million years old. If it had appeared as recently as 800 years ago, parts of the surface of the moon in and around the crater would still have been warm from the impact. The most likely explanation of what really happened back in 1178 is that observers were extremely lucky to see an asteroid falling towards the Earth and burning in our planet's atmosphere. The spectacle would have been incredible, and seen from a proper angle, the burst of the asteroid could have really looked like it was the moon exploding. That would explain why there were so few witnesses of the phenomenon. The right spot to see the show, as they did, was only a couple of miles wide. As for real events on the moon, water and oxygen were unexpectedly discovered on it not long ago. Water might have been brought to the satellite by asteroids hitting its surface, many of them carrying H2O molecules, and those that are left on the moon in tiny amounts after the impact. There's precious little water there, though. By comparison, even the Sahara Desert has more of it than the entire moon. Oxygen is also present as separate molecules floating around, so you still can't breathe on the moon. Solar wind brought them there. Waves of energy from the sun travel at extremely high speeds through space, scrape oxygen from the upper parts of our atmosphere, and carry it further. Eventually, the wind with the oxygen molecules reaches the moon. And that's where something incredible happens. The moon starts rusting. There's plenty of iron in the lunar soil, and when it's exposed to oxygen and water, it naturally rusts. Some parts of the moon have actually already turned slightly reddish. They're regions where there's the highest concentration of molecules. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from the corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's crescent-shaped. The flashes come and go very quickly, almost like lightning. And in fact, that's what they basically are, electric bursts. Tidal forces are to blame for this. They cause mechanical stress buildup in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. But still, there's so far been no green cheese discovered there, or moon pies for that matter. Disappointing, I know. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.